All right, so I wanted to touch base with you guys about your constructive responses. There are many theories to explain how the universe was formed. I'm sure you guys have heard of Big Bang, nebular, and planetesimal. You're going to need to explain at least two theories and how they compare and contrast, and which theory is most accepted and why. So today in class, what we've talked about this whole time are the planetesimal and nebular theories. With your planetesimal theory, remember that one is one that appeared to happen suddenly, um, whereas your nebular theory happened over a long period of time when the nebula was, combining slowly and swirling and moving. Okay, so that they're similar in that they both are explanations for the origins of the universe. They're different because one, the nebular happened over time, where the planetesimal is believed to be more of a sudden event. The one that is most accepted would be the nebular, and mainly just because it's hard for scientists to believe that things happen suddenly, and there's more evidence to support the nebular theory. Now, the geologic timescale spans for approximately 4.6 billion years. Explain what occurred in history that allowed humans to become in power. Also, which period the evolution of humans occurred. Okay, so they're saying that the Earth has been in existence for about 4.6 billion years. The big event would be that the dinosaurs um, died out. So that is when mammals and humans became the most powerful. That's when it became the most powerful, and it would be the Quaternary period when the evolution of humans occurred. Explain the relationship between density and whether items float or sink. How does this help explain why the Earth layers are often described as floating? Well, we know that if the object's density is higher than what liquid they're being placed in, then it is going to sink. If it is less than the density of the liquid there is being placed in, then it will float. How does this relate to our floating earth layers? Well, we know that the most dense layer is going to go all the way to the bottom, which would be the inner core, and that's because it has solid iron and nickel, which are metals which have a huge mass. So it's going to have more density, the most density, whereas your outer core is floating up above it because it's less dense, so it's going to float above. And the mantle is going to float above the outer core because it is less dense. And then our crust is at the very top with that very brittle, thin layer that is easily for us to drill in and damage. It's on that very top layer. So they're considered floating because the less dense is floating up above the more dense ones. The quantum drift theory was controversial when Wagner introduced his ideas. What evidence did he provide to support his ideas that the plates were once joined? Explain how each piece of evidence supported his theory. Why did they not accept his theory initially? And what piece of evidence did he provide to change their minds? Well, we learned in our Continents on the Move that there are three pieces of evidence. We examined the Appalachian Mountains and why there are mountains on different continents or areas, but in the same pathway where the ocean floor has no mountains. And so he just didn't think it made sense that there would be these gaps where there would be no mountains. So he believed that supported his idea that it used to be one big supercontinent. Glaciation, the fact that the scarring indicated that on different continents and areas, that scarring indicated they all moved in the same direction. So his premise behind that is that he felt that the fact that they all moved in the same direction, that indicated they also once used to be part of the same same big supercontinent. Fossils being located on different continents that are the same type of fossils. That's why when we took our continent cutouts and we placed them together, and we could see that how they could connect. We could make a line out of all the different, after we matched them up, the fossils, how it could have looked if it was one big continent. So it wasn't accepted because he couldn't explain or prove the movement of the continents. So what he did is he found evidence once I think it was World War II. I can't remember if it was World War I or World War II, but when they first started doing sonar, they were able to map out the ocean floor, and they could see this mid-ocean ridge, and they could date those rocks or the ocean floor, and the further out it was older than what was on the mid-ocean ridge. The mid-ocean ridge were the younger um, ocean floor, and the further out it was the older. So that to him proved that the ocean floor was actually moving. And so that's when scientists started believing that plate tectonics and continental drift theory were true. Explain relative dating, absolute dating techniques and how they differ. Well, with our relative dating, you're looking at rock layers and you're comparing the different rock layers to determine the age. You're using the law of superposition, uniformitarianism, cross-cutting, inclusion. And then you also had absolute dating, which was half-life, where we had mathematical calculations that we made to determine the age, the absolute age of a particular rock. So they differ because one is qualitative where the other is quantitative. The qualitative would be our relative dating because we're making observations. It's not mathematical, whereas our absolute dating is quantitative because it is mathematical. With our issues, you would need to explain how the Earth sphere is are impacted by human choices. Well, air pollution. We have tons of examples of how we impact our four spheres. Our geosphere is being damaged by all of the emissions, all the factory fumes that are being exerted into it. It's damaging and weathering and eroding our land. We also have our atmosphere is being impacted. It's depleting our ozone layer. It's also causing global warming. Our biosphere is being impacted because people, like, if you have asthma, that is something that is being caused or perpetuated by air pollution. So there are medical conditions. Also, with our hydrosphere, it is affecting the temperature of our water. So in beach pollution, same kind of thing. The trash that's being put into the ocean is impacting our hydrosphere and the marine animal life, our biosphere in the ocean. So in waste disposal has to do with trash, like the floating dump that is on barges that are in the ocean. So these are all different issues, and you just need to make sure that you can explain how they impact the biosphere, hydrosphere, geosphere, and atmosphere. And you get to choose one of the three. So it's not like you have to do them all. An archaeologist finds a fossil had formed when minerals replaced all or part of the organism, making it turn to stone. What type of fossil did he find, and what three things could he learn from his fossil? Well, it turned to stone, which would be an example of a petrified. There are three things we can learn from fossils. We get clues about organisms that lived long ago, how Earth's surface changed over time, and then helped scientists understand what past environments were like. With our next question, you're hiking on a hiking trip and you want to go on a hike in the mountains that follows the river flow. Although you want to climb mountains, you don't want to climb the steepest side. How would a topographical map help you determine the direction the river is flowing, as well as which side of the mountain is steepest? Well, we know that with our river, we look for that V, and it looks like it's pointing towards where it's flowing, but actually what it's pointing at is where the river begins. It's going to be flowing in the opposite direction. So and then also with the steepest part of the mountain, we're going to look for those rings to be close together, very close together, and that's your steepest. You're peer reviewing your classmate, and this is the work he submitted. What errors, if any, do you find? Explain. Convergent boundaries go apart and form mountains. Well, we know that's not true because convergent boundaries come together and form mountains and volcanoes. Divergent boundaries slide past each other and cause seafloor spreading. Well, divergent boundaries do cause seafloor spreading, but they are going apart, not sliding past each other. Transform boundaries come together and form volcanoes and cause earthquakes. Well, transform boundaries do cause earthquakes, however, they do not cause volcanoes, and transform boundaries slide. You're strolling through the woods and you find a cool footprint of what looks like a three-toed animal. You show it to your friend and they insist it is a mold fossil, but you think it is a trace fossil. Who is right? Explain. Well, a mold fossil is when hard parts of an organism are buried in sediment like sand, silt, and clay. Trace fossil are the activities of organisms, like footprints. So your friend is wrong and you're correct. It is a trace fossil. And that's the reason, because it shows it's a footprint, which is an example of an activity that animals do. So it's going to have a little footprint. I'm really sorry that this was late, but I really wanted to just go ahead and submit this to you so that you would have it to at least reference.